Let's talk about matrices. First of all, a matrix is a way to organize data, and clearly we have a lot of data going on here, and it's just a lot to take in. So first of all, let me just kind of write a couple things. This is plural for a matrix. I don't know what that random dot was for, but this is a way to organize data, and you'll see what I mean as we go. So the list below represents the number of students that are on the teams for the fall sports at AHS, listed by class. So we have seniors, juniors, sophomores, and freshmen for football, cross country, tennis, soccer, volleyball, and golf. Again, a lot of information, and it's a little bit overwhelming. So the practical aspect of this is that we're going to take all this stuff and we're going to make it in a very organized way. So number one says organize the data into a matrix. You'll see what we're talking about in a second. The rows should represent the sport and the columns should represent the grade levels. So let's do that. And so what we're going to do first is actually just list all of these. If you want to abbreviate, you can. I'm going to. So football, we're going to have FB. Cross country, put CC if you want. Some people put XC. I'm going to put CC. We're going to have tennis. I'll put TEN. That's going to look like the number 10. Soccer, SOC. Volleyball, VOL. And golf, which I am not going to abbreviate because it's short enough. So then what I'm going to do, I've kind of worked myself into a tiny space here, but that's okay. What I'm going to do is put a little bracket, and this bracket is going to be the beginning of all of our data, and our data is going to be seniors, juniors, sophomores, and freshmen. Okay, and we're going to close it with a bracket. So here's what's about to happen. All of this jumble of words right here is about to get organized into some very clear data that we can look at and just see exactly where everything is. So football, seniors, don't think too hard. Just put the right number in the right place. There are 24 seniors that play football. Now this would be even more tricky if they had mixed up some things, like if they'd have put freshmen first sometimes and then freshmen last sometimes. And we would really need to be cautious about that. 29 juniors play football. 32 sophomores play football. And 28 freshmen play football. Okay, so again, you might be looking at that saying, why am I doing this? I have all the information here. Look, I hear you. But again, sometimes this information is not as obvious or not as clear and not as well organized as this is. So this is taking something that's potentially sloppy and making it much cleaner and neater and easier to look at. So let's keep going. Cross country, 12 seniors. This is where things get really easy because you're like, I can read. Cross country, 11 juniors. Cross country, 9 sophomores. Cross country, 13 freshmen. There we go. Tennis, 8 seniors, 7 juniors, 10 sophomores, and 9 freshmen. Oh no, I've worked myself into a tiny little thing here because these got smaller as I wrote. All right, soccer, 14, 11, 13, and 15. 4, 6, 7, and 6 again for volleyball. And golf is, okay, now we have to be really careful with this one. And this is why matrices are very important because, again, they help us organize data. So I have 2 seniors that play golf. I have 4 juniors that play golf. And then I get in such a habit of writing numbers that I might be tempted to put a 3 here, and I can't. So I just need to be really cautious because there are actually no sophomores that are listed here. So I have, 0 sophomores. So I need to be aware of little things like that. And then freshmen, there are 3 of them. So there we go, we've done number 1, and they're not all that painful. We just take the numbers and put them in the right place. So then what are the dimensions of the matrix? So when I say that, what I really want to know is how many rows and how many columns. And there's actually another word that is often used for that. We'll talk about that in a minute. But I'm going to come over here on the side with a green pen and talk about this. This is going to be rows and then columns. And so I need to count how many rows and count how many columns. If we're going to say this a different way, I need to count how many sports, because those are my rows. Rows run horizontally. And then how many columns. So again, rows run horizontally, columns run vertically. So I have 6, 4, 5, 6 sports. And columns, I have 1, 2, 3, 4 different grade levels. So what are the dimensions? Final answer for this, I will write it right here. This is a 6 by 4 matrix. Okay, I put a gap between those numbers. What's going to go in between those numbers? I'm glad you asked. It's going to be this. Now, I know you're probably looking at that saying, oh, well, so 6 times 4? Actually not. This is pronounced as a 6 by 4 matrix, and so I'm going to kind of write that. So this is a 6 by 4 matrix. Now, I am well aware of the fact that this looks like 6 times 4, and actually that does have a practical application because, well, 6 times 4 is 24, and there are 24 numbers here. Okay, so that does tell me how many numbers are represented in my data, but I'm not technically supposed to multiply them. This is just my way of telling you what the dimensions are. Okay, one more word you need to be aware of, and it sneaks in sometimes. Instead of dimensions, they may use the word order. So they may say, what is the order of the matrix? And it's the same thing. So if you see, what is the order of the matrix, or what are the dimensions of the matrix, they're really asking you the same question. And the question they are asking is, how many rows do you have? I have 6. How many columns do you have? I have 4. Okay. So now we need to grab a calculator or something, some way of figuring out stuff. Now that we have all the data organized, we can do stuff with it. Okay, so again, you could look up here and say, oh, I have 32 sophomores and 9 sophomores and 10 sophomores, but now they're all in a row. Everything is neat and clean. So number 3, how many sophomores play a sport at AHS in the fall? Okay, so here's all our fall sports, and I just care about sophomores in order to answer this question. So all I need to know is this column. So again, one more time, you could have looked up here, but this is much cleaner and more direct. All right, so that's actually what we're about to do, and I'm going to write down some stuff that you don't have to write because you can clearly just type it in or do it in your head and get the right answer. But this is what I'm doing, +7. And just because I don't want to leave him out, I'm going to put +0. Feel free not to put that. That's okay. But what I'm doing is just adding up the sophomores, and we will get an answer for that in just a second. I'm going to try to do this in my head. I'm going to go backwards. That's 20, 30, 39 plus 32 is 71. I'm going to double check myself with a calculator. It is indeed 71. So there are 71. Now, I am perfectly okay with this answer, but I like to put things in context because this is a way to organize data, right? And 71 what? Well, the answer is right here, but I'm going to just write that so I do not lose track of what it represents. So 74 sophomores. Okay, now how many students play tennis? Okay, now let's be careful about the way this is worded. It said how many students play tennis, not how many seniors, not how many juniors. Students, like Alma seniors, Alma juniors, all Alma sophomores, Alma freshmen. So now I'm going to add up tennis. And tennis is 8, 7, 10, and 9. So 8 plus 7 plus 10 plus 9, and I think that's 34. We'll double check that. That's not 34, that's way off. Yeah, it is right, it is right. Okay, so 15 and 10 is going to give me 25. 25 plus 9 is indeed 34. Now, put the number 34, that's great, but let's make sure we understand what it represents. These are 34 tennis players. All right, again, we're just organizing data. All right, now we get to the crazy stuff. What percent of all volleyball players are seniors? Okay, now, you've heard of percents before. You've heard of it for many years. This is not an insult to anyone's intelligence, but I do find it necessary to not give shortcuts the first time I talk about percents, because you might have heard of like part over the whole and all this stuff, but I really want to just go straight to a process that will help us understand it better. So, percent of all volleyball players are seniors, and I'm going to do exactly what I just said, actually. We're going to do part over the whole. So the part over the whole is really going to be represented by something. We're going to call it percent over 100. And so when I'm trying to figure out a percent, this is really what's going through my head. So I'm going to have to kind of work through this. So the part. What percent of all volleyball players are seniors? Okay, so the part is seniors. The whole is all the volleyball players. I have to think about it. Which group is bigger? Seniors or all the volleyball players? Well, all the volleyball players, that's the big group. So what I'm going to do is find out how many volleyball players there are, and I'm going to take this idea and we're going to put some numbers into it. So the whole, this is going to be all volleyball players. So all my volleyball players would be 4, 6, 7, and 6, and so 4, 6, 7, 6. If you wanted to go ahead and add them together before you write this step, that's cool. But I have a feeling that if I was to write 23, which is what it is, then people might be like, wait, how'd you get 23? You're making that up. Okay, this is all volleyball players. And these are senior volleyball players. So just the senior volleyball players, which would be 4. So just 4 of them. Okay? And that would be the percent out of 100. Now, it did ask for percent, so that's what I don't know. I'm going to call it X, call it N, call it P. Keep the percent sign, do whatever you want, but I'm going to put that over 100. And before I go any further with the very basic algebra that you have all done before, let me just label a few things. These are senior volleyball players. And these are all volleyball players right here. So this is the part, this is the whole. Senior volleyball divided by all volleyball. So let's keep moving. I'm going to take this work and bring it over here. We're almost done with this one, actually. So we have 4 over 23 equals something over 100. And I believe at this point we can just do it. So let's cross multiply because we know what we're doing. At this point, 4 times 100 is 400. 4 times 100. And then we're going to do 23 times x, and that's going to give me 23x. And now we're just simply going to divide. Now, and when we're done, we're going to be able to say, hey, this percent of all volleyball players are seniors. And it will be the same proportion as 4 over 23. We're going to divide by 23. You have seen this type of work before many times, I'm sure. I'm grabbing a calculator that you can't see. It's off camera. Whoa, now it's on camera. There it goes. 400 divided by 23, and it's going to give me this. Let's round. I like to round to 2 decimal places. That's just how I roll. You round however you like for now. 17.39%. So you walk up to the volleyball coach and you say, what percent of all volleyball players are seniors? And that volleyball coach would say, well, you know, I have 4 seniors, I have 23 total, and if we were to treat that as if it was something over 100, it'd really be like 17 out of 100. If there were 100 volleyball players, about 17 of them would be seniors. Now, you can't have 17.39 seniors, but, you know, we rounded. All right, number 6, what percent of students that play a sport are volleyball players? Okay, now things are going to get tricky. These are all the students that play any sport. So now I have to add everything. Okay, let's make sense of this. It's asking for a percent. So we're going to do this again. Part over the whole equals percent over 100, right? So what percent of students that play a sport? Oh, that's the whole. That's the whole thing is going to be all students that play a sport. So let me write that. That might make a little bit of sense if I do. Students that play a sport. Students that play a sport. That right there, my friends, is the whole. And then volleyball players, that is the part. So the part divided by the whole equals the percent over 100. Okay, so let's figure out some stuff here. I'm going to leave a little bit of work out, and the part that I'm going to leave out is just all this adding that we have to do. So let's do the easy part first. How many volleyball players are there? Well, there are 4 plus 6 plus 7 plus 6, and we actually already did that. 4, 6, 7, 6 was 23. Okay, so how many volleyball players are there? There are 23. I'm just going to put that right here so we can kind of keep it in our head. And then students that play a sport. All of them. So this is going to take a little bit of work. I want to know how many students play a sport, and that's this. I need to add all of these together. Is there a shortcut? No, I'm sorry, there is not. So let's just type this in very quickly. 24, 29, 32, 28, there's football. 12, 11, 9, and 13, there's cross country. 8, 7, 10, and 9. 14, 11, 13, and 15. 4, 6, 7, 6, 2, 4, and 0, and 3. There are 277 athletes in the fall, assuming I typed that correctly. So, the whole is 277. Okay, there it is. So let's just kind of keep setting this up, and this will work itself out as we go. So we have the part, volleyball players, over the whole, 277, equals the percent, and that's what they're asking for. That's what we don't know. What percent? I don't know. We'll call it X, or call it whatever you want. And that's going to be over 100, and we'll cross multiply. And when we cross multiply, we'll bring our work over here. I'm going to use an arrow just to kind of bring my work over. I can't say equals because this step is going to lead to that step, but they're not technically equal. So 23 times 100, so 2300, equals 277x, 277x, and we'll divide by 277. You've seen this work before. 277, so whatever 2300 divided by 277 is, I'm grabbing a calculator, I'm typing, I'm having fun. I get 8.30. I'm going to leave that last zero off. So 8.30%. So let's suppose there's a pep rally, and they're going to call every athlete's name. About 8 out of every 100 athletes will be a volleyball player. That's what that means. So if they're going to call all 277 names, that'd be a long pep rally. But if they were going to do that, then out of every 100 people they named, 8 of them, approximately, would be a volleyball player. All right, now we get into some different notation. All right, so let's kind of take a look at this. First of all, I'm going to slide back up to the top, and I'm going to write a little bit more. Plural for matrix in a matrix is a way to organize data. Matrix. A way to organize data. Whatever information I need. And I'm keeping that in mind as I go into the next 3 questions, which are going to be pretty straightforward. All right, number 7, we're going to call this matrix A. So over here under number 1, I'm actually going to just put a great big A, and I'm going to say A equals this. So this matrix is A. This big old matrix is just A. That's it. And we're going to call it A, and then it says, what is A23? Now, I know that looks like 23, but technically it's not. For some reason, somebody decided that we don't need a comma there. I don't know why. It bugs me too. But the technical mathematical notation is A23. All right, so let's talk about what this means. If big A is the matrix, then little a represents a number in the matrix. All right, now which number is it? Glad you've asked. The number that it is going to be the second row, and you guessed it, the third column. Okay, and so if I'm dealing with matrix A and then they start asking about little a, they want to know a specific piece of information, one little bit of the data. So what I'm going to do is look in my matrix and go to the second row and the third column, and I'm going to pull that number out, and then I'm going to talk about what it means. So let me grab a pencil because this is really handy to do it this way. I need the second row, third column. All right, here is my first row, which was football. Second row, which is cross country. So here's my second row. I'm going to do this very lightly. Here's my second row and my third column. First, second, third column. 9. So number 7 is asking me to identify what's right here, and it's 9. And I need to tell what it means too. It's not just 9. 9 what? 9 cross country players that are sophomores. So there are 9 sophomores that play cross country. Let's answer that. What is it? It's 9. What does it represent? 9 sophomore cross country, well, I'll call them runners. We won't call them players. All right. Let's do these last 2 right here. And I'm going to introduce you to one more little definition. Okay, what is A 4, 3? Well, I'm going to state the obvious here. Obviously, I'm dealing with matrix A. If we had more than one matrix, this would really tell me which matrix I'm going to be dealing with. So this is my 4th row, and this is my 3rd column. So we're going to go to the 4th row in the 3rd column, and let's just do it. 4th row is not cross country. Now, y'all don't have to circle like I'm circling, but I'm doing that because, well, it's going to be helpful to identify things. So 4th row, football, cross country, tennis, soccer. 3rd column, seniors, juniors, sophomores. 13, sophomore, soccer players. All right, cool. Let's write that down. 13, sophomore, soccer players. I misspelled soccer, and I'm highly embarrassed right now, but I'm not going to start this video over. Here, I'll put a little tail on that. There we go. Soccer players. Terrible handwriting. All right, last problem, then one more definition. And then we'll jump to the next problem, the next video. What is A14? All right, here we go. First column. Oh, sorry, first row. Always rows first. And then 4th column. Sorry, I'm going to get my life straight here in a second. 4th column. And first row, 4th column. Let's see. I'm not going to circle it this time. I'm just going to point. First row, football. 4th column, freshman. Football, first row. 4th column, freshman. And that's supposed to say C-O-L, but it really doesn't look like it at all. Let's make that more like a C-O-L. There we go. So it would be 28 freshman football players. All right, quick definition. We're going to squeeze it in the bottom. I'll write it in red. A specific number in a matrix is called, my hand gets ahead of my brain sometimes, an element. There we go. There's your definition.